Hello students, once again welcome to the LG Institute of Engineering and Technology. Let's start with the course Mathematics 1. Today's chapter is partial derivatives and today's topic is chain rule, but this is partial differentiation of composite function of two variables. In previous lecture, we have seen total differentiation of composite function with single variable, and here it is partial differentiation of composite function with two variables. Okay, so let's understand this topic with our different point. First, chain rule for two independent variable and two intermediate variable. So what is two independent variable? What is two intermediate variable? Let's have a look on this statement. W is a function of x and y, and x, where x is a function of r comma s and y is a function of r comma s. So we can write like this, w is a function of x comma y, so that means w is a function of x. So x is given by g of r comma s, and y is a function of h of r comma s. So ultimate, we can say that this w is a function of r and s. So then w is a function of r and s and is called composite function of two variable r and s. So this is composite function of two independent variable r and s with two intermediate variable. That means if we write w is a function of x and y, and x is a function of rs, y is a function of rs. So if w is a function of r and s, as we have seen, this w is a function of r and s, but with two intermediate variable, that means this x and y are called intermediate variable, as we have seen in previous lecture. Okay, so if we want to differentiate this w with respect to this independent variable r and s, we have to use this intermediate variable x and y. So partial derivative of w with respect to r and s is given by these two formula. That means del w by del r is equal to del w by del r is equal to del w by del x by del r. Same way, this go through x, and now we go through y, because y is also containing r now. So therefore del w by del r, del y, and del y by del r. Same way, del w by del s is given by del w by del x and del x by del y. That means we go through this path, and same way by this del w by del y and del y by del s. Here each and every derivative is partial derivative, because w is also containing two variables, that means more than one variable, and x and y is also containing more than one independent variables. Okay, that's why we will use partial derivative. Okay, and in previous lecture it was total derivative. Same way, if this we have three intermediate variable instead of two, then we have this topic, chain rule of two independent variable but with three intermediate variable. That means w is a function of x, y and z, and x, y, z is a function of r and s. Got it? So we have three intermediate variables. Okay, so then we can say that w is a function of r and s, as I told you. Okay, and is called a composite function of two independent variable r and s, and therefore partial derivative of w with respect to r and s, derivative of w with respect to always these two variable, not with these three intermediate, because x, y, z are intermediate only. So it is given by del w by del r. So x, y and z, all three intermediate variable contain r, so we have to go through x, y and z. So w with x, x by r, w with r, r by w with y, y by r, w with z, z by r. Same way, if you want to find del w by del s, same x, y and z, all these three intermediate variable contain s. So same del w by del x by del s, del w by del y by del s, del w by del z by del s. So these are the formula for partial derivative of composite function with two variables. So let's have a look on the example and understand this topic better. First example, we have express del w by del r and del w by del s in terms of r and s if w is given by this function, that means w is a function of x, y, z, and x is given by r by s, y is given by r square plus ln s, and z is given by 2r. So before starting example, if you got this idea that this is the chain rule, then just make this kind of chart. That's w is a function of x, y, z. It is clearly shown here. W is a function of x, y, z, and x is a function of two variable r and s. Again, y is a function of r and s, and z is a function of only r. So we just write r. And if this kind of chart is happened, then we will use chain rule. Okay, here we have these two independent variable, so we will here use partial differentiation. And in previous lecture only we have this kind of example. W is a function of x, y, z, but this x, y, z is a function of t only, and that's why we use total derivative and chain rule. This is partial derivative and chain rule. Okay, so now let's start with the solution. First we will write down the w and x, y, z. Okay, now by using partial derivative and chain rule, first we will find del w by del r. So del w by del r is given by the formula as we know. So we have to find with respect to differentiation of w with respect to r. So we go through x, y and z. This x, y and z. Okay, so now we will find the del w by del x, which is differentiation of w with respect to x is 1. Del x by del r, differentiation of this x with respect to r, so x is constant, differentiation of r is 1, so 1 by s. Now del w by del y, so differentiation of this, so we know that partial derivative with respect to y, at that time x and z treated as a constant, so differentiation of these two is 0 and differentiation of 2y is 2. Now differentiation of y with respect to r, that means 2r, and differentiation of this is 0. Now same way del w by del z, as we have discussed in previous lecture, I have given many example for practice. If you did that practice, then these are the so easy for you, and if you did not practice, then you know where is the problem. Okay, so again I am telling, do practice regularly. So del w by del z is 2z, and del z by del r gives derivative of z with respect to r is 2. Now by simplifying, and also it is given that find these two in terms of r and x, so we have to convert x, y, z, we have to replace x, y, z with this value. So here no x, no y, but z only, so we will put 2r, and so we have this 2r, that means 2r, that means 2 to the 4 and 2r, and this is 4r and this is 1 by s. So we have final answer is 1 by s, 4r plus 8r is 12r. Same way we can find del W by del S. This is the del W by del S process. Have a look. We have W, X, Y, Z, and by partial derivative chain rule, del W by del S is given by this formula, and we will find the derivatives, and we will put the value of Z, but this 0. Why this del Z by del S 0? Because Z is containing only R, no S. So differentiation of 2R is 0. Constant. That's why. So we have final answer minus R by S square plus 2S. This is our final answer in terms of R and S. Okay. Now let's have a look on one more example. We have this example. If u is a function of this x minus y, comma y minus z, comma z minus x, then prove that del u by del x plus del u by del y plus del u by del z is equal to 0. This is quite different from this previous example. In previous example, it is clearly given that w is a function of x, y, z, and x, y, z are a function of r and s. And here you have to make that function. So first we have this u given. Now if I will take this term, that means x minus y is r, y minus z as s, and z minus x as t. So we have r, s, and t. So this given function u becomes, u is a function of rst, and rst is a function of xyz. So we have u is a function of this time rst. Make a concentration over here. U is a function of rst. Okay, so don't mug up. Just we have to remind, and you have to write this function. These are the intermediate variable, and r is a function of x, y, s is a function of y, z, and t is a function of z, x. So we have this r, s, t are only intermediate variable. So we have to differentiate only with respect to this variable x, y, z. And here it is also asked in the question. So first we will find del u by del x. For that we will make chain del u by del r by del x. Similar way, del u by del s by del x, but in s there is no x, so this term will be 0. And similar way, del u by del t and del t by del x. Okay, so by finding this derivative, del u by del r, that means differentiation of u with respect to r, but here there is no any function is given, so del u by del r as it is. Now del r by del x, so differentiation of this with respect to x, which is 1 minus 0, that is 1. Now as we discussed that s did not contain x, so differentiation of s will be 0. And differentiation of u with respect to t as it is, because function is not mentioned, only f, and del t by del x, which is minus 1. Okay, so by simplifying this, we have del u by del r, and this plus minus minus del u by del t. This is equation number 2. Similar way, we can find del u by del y. So we have this given, and del u by del y, but this time which function did not contain y? This t, so this will be 0. So we have this 2 term, and by simplifying we have equation number 2. Same way we can find with respect to z, and this time this r has no z, so this term will be 0. And we have this 2 derivative, and we know that del u by del s, del u by del t as it is, because u, which is this function, is only f of this. There's not particular function is given, that's why. Okay, so by simplifying this, we got equation number 3. Now we will put equation number 1, 2, and 3 on the left hand side. This equation number 1, 2, and 3, and by opening this bracket, by cancel out this term, we have this plus and minus, this minus and plus, and this plus and minus, we will get answer 0. That is our right hand side. Simple example. Okay. So this is second type of example. In first example, w is a function of xyz is given and xyz is a function of rs is given. In this example, we have to suppose that rst and we make the function. Okay. Now one more example which is quite different. Okay, let's have a look on the question. This is second order derivative. In this chapter, in previous chapter, we have seen only first order derivative. So this is totally different from previous two example. So take a look and just pay more attention. So let's start with the given function. Capital V is a function of x and y. So just first we will make the chart. Capital V is a function of x and y, and x is a function of small uv. So make concentration also on the variable. That means we have taken capital V, small v, capital V, uv. Okay. So x is a variable of small u and small v, function of, similarly y is a function of small u and small v. So we can differentiate this u with respect to small u and small v because x and y are intermediate variable. So we will find del square v by del u square and del square v by del v square 1 by 1. So let's start with the question. V, x and y is given. First we will find del capital V by del small u. Okay, so by chain rule, del capital V by del x and del x by del small u. Same way, del capital V by del y by del small u. Now we don't have these functions, so del v by del x and del v by del y as it is, and differentiation of x with respect to u, small u, and differentiation of y with respect to small u we can find from these two. So differentiation of u is e raised to u, sin v constant, differentiation of e raised to u is e raised to u, cos v constant. So we have this. Now we can write down the value of these two because we have e raised to u sin v is x and e raised to u cos v is y. So put the value of these two. So we have this answer. Now from this we can drop this v and v. So this equation becomes del by del u similar to x del by del x plus y del by del y. Just by dropping this function u, we have this two. Why we just use this logic? Because in this rule, then that means partial differentiation and chain rule, whenever we want to differentiate second order, we have to use this concept. So you can understand better. Now del square v by del u square, which is given by, or we can write this by del u of del v by del u, as we have discussed in first, second, third lecture. Okay. So this gives against del square v by del u square. Now we will put the value of this del by del u from here and del v by del u from this. So we have this two bracket. Now we will apply this x into del by del x to this bracket and y into del by del y to this bracket. So we have this term, del by del x of bracket and del by del y of this bracket. Now x is outside from this differentiation, so x as it is, and we differentiate this bracket with respect to x partially. So you have to pay more attention over here. Now we want to differentiate with respect to x, so this x and v itself function of x and y. Okay, so we will use product rule here. So this x as it is, and applying product rule, x as it is, differentiation of del v by del x with respect to x is del square v by del x square, plus now del v by del x as it is, and differentiation of x with respect to x is 1, plus this y is constant because we are differentiating with respect to x partially. So del by del x of del v by del y gives del into del square v by del x del y. Okay, same concept we will apply for with respect to y. That means this y constant, and if we differentiate partially with respect to y, so this x constant, and differentiation of del v by del x with respect to y gives del square v by del y del x, plus this y into del v by del y gives product rule because we are differentiating this time with respect to y. So first y as it is, differentiation of del v by del y with respect to y is del square v by del y square, plus this del v by del y as it is, and differentiation of y with respect to y is 1. Now just opening the bracket, that means this x will multiply to this 3 term, this y multiplied to this 3 term. We have this simple only bracket open expanding. Now here you can see that this term and this term are same as we have discussed mixed derivative theorem. Okay, so we can write down this 2 times, and we have remaining this 4 term as it is. So 4 term as it is, and these are 2 times. So equation number 1. Same way we will find del square v by del v square. But for that, first we differentiate with respect to v. 1 time we will get this. Now this is our y and this is our x. So minus x. So we have this. By removing this v, we get this similar, and to find del square v by del v square, small v, capital V and small v, you have to make clear. We can use del by del v of del capital V by del small v. We have these two value from previous step. Okay, now we applied y into del by del x to this bracket, and minus x into del by del y to this bracket. So we have this. Now as we have discussed in this example, y constant as it is, and we differentiate this bracket with respect to x. So we have this y constant, and because we are differentiating with respect to x partially, so y constant and differentiation of del v by del x is del square by del x square, minus this product rule for these two. So this term as it is, and differentiation of x is 1, minus, why minus? Because this is minus, and in product rule we have that plus in between. So now del x as it is, and differentiation of this term with respect to x is del square v by del x del y, same way this. Now by expanding this bracket we have this, and we can use this mixed derivative theorem because it is already verified. So this is 2 times, and all the 4 terms are as it is. Now from equation number 1 and 2 we will put this in left hand side, and by simplifying, by cancel out, or whichever these 2 terms will be cancel out, this term will take together. But okay, x square, where is x square? We can take common. Y square we can take common, and we can cancel out this term with this term with this, and we can take this bracket common. So we have x square plus y square, and this is our right hand side. So this is quite different and quite difficult also. So pay attention and keep rewinding and see again and again. Use pen and paper so you can understand better. So this is today's topic, partial differentiation and chain rule. Okay, so these are the example DIY that you have to do it yourself, and by practicing this you can understand this topic better. So keep practicing, keep learning, use pen paper, and we will see you with next topic. Thank you very much for watching this video.